Okay. Duh. Laplace transform T is 1 over S squared, right?
Oh, yeah. Okay.
Yeah, I knew that here, and I just wrote it down carelessly, as I'm prone to do. Okay? So that makes this an S cubed, S to the 4th, S to the 5th, and an S to the n plus 1. Right? Did you get that by working it out, or did you look at the table?
I got by working it out.
I figured you did. It looked like you were doing the right stuff.
When you did the 3 over S times 2 over S cubed, that's kind of when I figured it out.
Yeah. Yeah, you see the pattern pretty quickly.
Yeah.
Because what I ask you to do on the worksheet is just do it up through S cubed, then what's going to happen for S to the 4th? I mean T to the 4th.
Yeah.
Okay? Because at that point, you probably, if you've done the U substitutions, you see what's going to be happening down the line. And you know, you might do this, you might not see the factorial at this point, but when you then, if you do this one and then ask yourself about this one, it's pretty clear that you got a factorial. I mean, we already said here, well, there's a factorial involved. So before I even asked this question, okay? So I knew that you were going to get this, and you would have had it right if I'd had this right. But I started off with 1 over S. Incidentally, the Laplace transform of the function that's constant equal to 1 is clearly 1 over S. Okay?
Right.
So this formula applies for n equals 0 to infinity, for any integer from 0 to infinity. Okay? Then you might ask, does it apply if t isn't an integer? Well, that gets tricky because if t is not an integer, then you never get down to a multiple of L of t, right?
Like if it was a sine or cosine.
Well, we'll deal with that, okay?